Welcome back. This is Mr. Marshall for Truganina College, Year 9 Maths. Today we're looking at Algebra Misconceptions. This unit of work is Algebra Misconceptions. You'll need to read and copy the learning intentions and success criteria into your exercise book. We'll be going through the slides. You'll need to pause it to take notes, and then you'll be answering the questions found at the end of each slide based on the worksheets in your study pack. Today we are learning to substitute in sequential values into an equation, and I am successful when I can replace the pronumeral with a range of values, recognize patterns created by substituting in sequential numbers, work out a next number in the sequence, and work out the missing numbers in a table. And for a challenge, see if you can predict patterns formed from the equation before substituting in values. So just a reminder, when we're doing substitution, wherever that x is, we're going to replace it with a 3. Now, one way we can do this is we can write it like this, which is actually, this is 10 times 3. If we have the brackets there and no symbol, it just means there's a times in between. Okay, it's another way of writing it. So we've got 35 minus 10x. This becomes 35 minus 10 times 3. When we use our knowledge of maths, 10 times 3 is 30, so 35 minus 30 is 5. So how does this help us solve this equation? You need to think about that. So substituting into a table. So we're going to have a quick look at how to substitute into a table. For each value, and it's usually the top row, we substitute into the equation and solve for the output, which is usually the bottom row. As we start to solve sequential numbers, we might notice a pattern forming, and that pattern will continue. So here's an example. This one's not quite the way that we set it up. Down the left hand side we have our x's. Here's our equation. Here's our working out for each input, which is the x, and here's our output, which is the y. And so we can say that when x is 0, we put it into our equation and we get 5. When x is 1, we get 6. When x is 2, we put it into the equation, we get 9. So that's our workings. Let's go through a couple more worked examples. So here's an example. We have our equation, b equals a plus 3. So first step, after we've drawn up the table and we've put in our values for the input, or a in this case, we start with our b. We'll start with this first one here. So we go a equals 0, so b equals, we substitute in 0 for that a, 0 plus 3 equals 3, and then we substitute that into our table here. Now, this is our working that we do in our heads. So you will start by writing this down, but as you get more practice at this, you'll start to do this in your head. So the next one, a is 1, so we do the same thing, a equals 1, replace it in the equation, 1 plus 3, which equals 4, and we put that in there. The next one, a equals 2, so 2 plus 3 equals 5. We're starting to see a pattern here. Let's check it out. A equals 3, 3 plus 3 equals 6, and we can see that each one of these is increasing by 1. So we expect the next answer to be 7. We will check it out just to be on the safe side. A equals 4, 4 plus 3 equals 7, so we've got that right, and then we can work out that last one as well. You will start to see patterns forming when you're doing questions like this. Here's another example. Y equals x over 3. Now remember, this over is really a divide. Our x's here are going up by 3s, they're not going up by 1. So we've got 3, 6, 9, 12 across the top for our input, and our output we're going to work out. So same thing. we're going to go x equals 3. There's our 3. We put it into our equation. 3 divided by 3 is 1. So we put the answer there. We do it again. X is 6. 6 divided by 3 is 2. Next one, 9. 9 divided by 3 is 3. And we can start seeing a pattern here. We think it's going to follow through, and we can always test it by substituting it in. Okay, the last one, this one's a little bit more difficult, but we can get the same ideas. So n, we've got our inputs up the top, 0 through to 5, m we're working out. Here's our equation, m equals 3n minus 1. So again, we start, n is 0, 3 times 0 minus 1 equals minus 1. We put it into our table. The next one, n is 1, 3 times 1 minus 1 is 2. We put it into our table. Now you might be able to start getting a guess of what's going to be happening, but we'll check a couple more times. N equals 2, 3 times 2 minus 1, 3 times 2 is 6, minus 1 is 5. And we'll put that in there. And then we do the same. N is 3, 3 times 3 minus 1 is 8. That goes into there. And we can see that it's increasing by 3s. So we could take a guess and say, we think the next answer will be 11. Let's check it out. N equals 4. M equals 3 times 4 minus 1. 3 times 4 is 12. Minus 1 is 11. So our guess was right. And therefore, the last one's 14, and we can put that into there. So after you do 3 or 4 numbers, you should be able to get a good idea of that pattern that's going to be forming. So our worksheets today on our pack for students on practice level, just doing question 1 and 2. Students on consolidating level, doing questions 1 and 2 and 3A and B. And students on the master level, just doing 1C and D, and then doing all of question 2 and all of question 3. Our reflection today, what is the relationship that you can see between the rules and the table that we make up? And you'll start to notice these relationships as we do more tables.